Alright, algebra students, this is the 3-3 skills practice for rate of change and slope, and I thought I would just show you how we compute each type of problem. You've got basically this type here where they show you a graph, this type here where they show you coordinates. Down here you have to solve for one of the coordinates when you're given the slope, and then on the back you have word problems. So starting with the first one, you are given a line with points 2, 5 here at the top, and then down here on the closer to the y-axis you get 0, 1. That's in fact the y-intercept. So you have these two coordinate sets. You have 0, 1, and you have 2, 5. Important thing to think about, which one of these is my x value, which one of these is my y value. Okay, so here is an x value, here is a y value, here is an x value, here is a y value. Now, which one of these is x1 and x2 and y1 and y2? Well, in this case, this is going to be x1, and this is x2, this is y1, and then 5 is going to be y2. Now, there are multiple ways to solve this. You know how to do stat, edit, stat, calc. Stat, edit, stat, calc, and then linreg, open parentheses, ax plus b. So you know that one. We've already learned that one. There's a simpler way when all we want to find is the rate of change. Okay, so the rate of change for this graph, this is a linear function. The rate of change for this graph is going to be the slope. All right, and the slope is represented by the letter m for slope. So in order to compute these values, there's a formula for slope. That is m equals y2 minus y1 over x2 minus x1. And this computes the rate of change, or the slope. So let's plug in what we know. We know that x2 is 5, or rather y2 is 5 and y1 is 1, over x2 is 2 and x1 is 0. So now we just kind of solve for the numerator on top and the denominator on the bottom. 5 minus 1 is 4. 2 minus 0 is 2. So you have 4 over 2. Now 4 over 2 simplifies to just 2. So in this case, m equals 2. Or if you prefer, since this is called rate of change, the rate of change equals 2. Okay, or the slope equals 2. So now you've got the algebraic way of solving it. When you use your calculator, there's a way that you can put this into your calculator very quickly. So you're going to go to the home screen on your calculator. Make sure you clear everything out. And then hit the alpha key. Okay, and then hit the y equals key. And when you hit the y equals key, this little menu pops up, and you're going to choose n over d for numerator over denominator. And that's going to put one of these guys inside your calculation window. Okay? Now up here is where you're going to put y2 minus y1. And down here, you're going to put x2 minus x1. So in the numerator, or up on top, you put y2 minus y1, and the denominator, you put x2 minus x1. The benefit of doing it this way is, when you use the stat edit stat calc linreg method, you get a decimal if there was a fraction like 2/3. But if you use this method right here, or if you use the algebraic method by hand, you will come up with a fraction. It'll give you a fraction. So it'll say 2/3 instead of 0.66666 forever. But that's how you do, 1, 2, and 3, or solve like that. 4 through 19 are even simpler because you don't have to pull anything off the graph. It's just given to you. So in these examples, you just need to know that this first number and this first coordinate pair is x1. The first number in the second coordinate pair is x2. The second number in the first coordinate pair is y1. And the second number in the second coordinate pair is y2. So again, y2 minus y1 over x2 minus x1. Be careful when you get to problems where you see that, like on number 6 and number 7, both of these problems have x values that are the same. x1 and x2 are the same. When we see values like this, like let's take number 6. Okay, number 6. By the way, this was number 1, if we're keeping track. This is number 6. You have 4, 6 for your first coordinate pair, and then 4, 8 for your second coordinate pair. Now let's plug it into our formula. M equals y2 minus y1 over x2 minus x1. Let's plug in what we have. We have 8 minus 6. Down on the bottom, we have 4 minus 4. So let's bring the calculator into this situation. If I bring the calculator into the situation and I use my new trick of saying sec alpha y equals, and then I choose the first one, n over d, I put in 8 minus 6. Down on the bottom I put in 4 minus 4. Watch what happens to the calculator. It gives me an error. It's trying to divide by 0. Well, so it doesn't work on the calculator. Well, that's because on top you have 2, and on the bottom 4 minus 4 you have 0. So this is undefined. All right, now why is it undefined? Why is M is undefined? Why is M undefined? Well, look at it. If I graph this, all right, I just graph this on a graph. I'm looking for x coordinates and I'm looking for y coordinates. So let's call this, this is the x-axis, this is the y-axis. Let's call this 4, and then we'll plot these 2 points as 6 and 8. So let me use my coordinate pairs again. Let me plot 4, 6. So I'm going to go over to 4 and go up to 6 and plot that point. Okay, now let me do the next one, 4, 8. I go over to 4 and I go up to 8 and I plot that point. What do we notice about this? If I try to draw a vertical line through these, I'm going to hit the points twice. So this fails the vertical line test. Is this a function? No. So it's undefined because 4, 6 and 4, 8 are not coordinates of a function. In fact, if we were to graph this, it would just be a vertical line at x equals 4. So the equation for this line is actually x equals 4. There's no y value. So we can't perform a rate of change. You know, there is no rate of change. Right? So that's how you would answer problems where you find out that the denominator goes to 0, right? And the way you don't even have to work the problem out. If you see that the x values are the same, you can automatically deduce that m is going to be undefined. Because if you start to know this formula real well, you'll know that those 4's will end up being 4 minus 4. Okay? That's why. Okay. So that's and the rest of these problems are just worked out like we did number 1. You plug in your values and you'll get it. Now, I want to come back to numbers 20 through 25 here in a minute. But first, I want to look at these values on these questions on the back of the page. Word problems involving rate of change. Let's look at number 2. When the dependent variable stays the same, when the dependent variable stays the same as the independent variable increases, the rate of change is positive, negative, 0, or undefined. Uh-oh, it looks like we need to know what dependent and independent are. Okay, so hold on to, and let's look at number 9. Okay? So as a teacher who has gained and lost a lot of weight, I feel like this problem resonates with me personally. It says here on number 9, a teacher weighed 145 pounds in 1986 and weighs 190 pounds in 2007. Okay, what is the rate of change in weight? Well, here's what we're given. The teacher weighed 145 pounds in 1986 and they weigh 190 pounds in 2007. So what is the rate of change? Well, the very first question we have to ask is, what is the dependent and independent variable in this word problem? All right, so let's label our variables. This is going to be weight, and this is going to be time. So the question we have to ask is, does the teacher's weight depend on the time or the years that pass, or does the time passing depend on the weight? In other words, does time stand around looking at its watch saying, what does the teacher weigh? And then only then will I increment my second hand. I'm going to wait and find out how much the teacher weighs. That's not what time does. Time doesn't wait for anybody. Okay? So time is independent of weight. But weight, the teacher's weight, depends on time. Okay? So weight depends on time, not the other way around. And we know that y is our dependent variable and that x is our independent variable. Okay? That's DEP for dependent and IND for independent. Okay, so given that we know that, we can assign our x1, y1, x2, y2. So what we're going to do is call this x1, and this will be x2, this will be y1 and y2. Okay, well now that we've gotten this, you can solve, right? So in this case, we're going to look at our slope formula. Our rate of change formula is going to be y2 minus y1, and that is divided by x2 minus x1. let's plug in our values. Okay, y2 is 190. y1 is 145. Okay, x2 is 2007. And x1 is 1986. Well, we could solve that by hand. Always fun. Or we could plug it into our calculator using the alpha y equals trick. Enter on n over d and put 190 minus 145 up on top in the numerator and 2007 minus 1986 on the bottom. And you get 15 over 7. This equals 15 over 7. If you care, you can stop right there, and that can be your answer, 15 sevenths. If you want, you can divide 15 divided by 7 and get a decimal, but this is better because the decimal appears to go on forever. 2.142857143. And you know, it probably goes on. So a more accurate, or rather exact, way is to leave it in an improper fraction form. So this is an exact solution, and this is an approximation. Okay, just that's a little extra. Now, if you wanted to write this as a proper fraction, you would say 15 goes in, or 7 goes into 15 two times, and how much remains? Well, 7 times 2 is 14. So you end up with 1 left over, and so you have 2 and 1/7, if you wanted to write it like that. But really, because eventually we want to get into looking at the slope as rise over run, it's actually better to leave it in this improper form. So 15 over 7 is the answer we're looking for. Okay, now that we've looked at dependent and independent variables a little bit, number 2 might make more sense. Let's look at number 2 here on the back page. So imagine a fraction input like this. So this is your alpha y equals n over d. That's your symbol all blown up like that. And we said that the dependent variable was y and that the independent variable was x. So this is going to be the dependent variable up here, and this will be the independent variable down here. So this is y and this is x. Okay? So let's look at number 2. When the dependent variable stays the same, and as the independent variable increases, the rate of change is what? Well, it's easy to do it like this. Let's start with the rate of change at 1 over 2, 1/2. So the dependent variable is 1, and the independent variable is 2. Right? Well, graphically, if I look at this graphically, let's draw it as a square. 1/2 shaded in looks about like this. Okay? So there's your current rate of change. Now, it says the dependent variable stays the same as the independent variable increases. Okay, so just follow the wording. Let's increase the independent variable, and let's leave the dependent variable alone. In fact, let's, just for fun, let's do 1 over, and then we'll double the independent variable to 4. So now we have 1 over 4. Well, you know, you might just think about the size of 1/2 and 1/4, but if you wanted to see it drawn, you could draw it. In this case, this is my new portion of the square taken up by that fraction, 1/4. All right, so the question is, what happened? What happened between here and here? Well, the answer is, it got smaller. Okay, that's pretty clear. So let's go back to the question. When the dependent variable stays the same as the independent variable increases, the rate of change is, well, just look. Is it positive or negative? Well, it got smaller, so the rate of change would be negative. Okay. Another way to look at this is saying, as the numerator stays the same and the denominator goes up, what happens to the overall fraction? It gets smaller. So this goes from 0.5 to 0.25. It's like you had 50 cents and somebody took a quarter away. Now you only have 25 cents. So by increasing the independent variable, okay, but not touching the dependent variable, the whole rate of change went down. It went down. It got smaller. Okay, so that's how you do numbers 1 through 4. You kind of have to put your brain to it like that. Now, we're going to take a look at equations or problems 20 through 25. Find the value of r. Here's the directions. So the line that passes through each pair of points has the given slope. Okay, so here's how the question will be worded, and here's how you solve the problems. Let's look at number 20. So this was number 2 on the back. This is number 20. Okay, on front. You are given r, okay, so already a variable, and then 3, and then you're given 5 and 9, and you're told m equals 2. All right? Well, let's take a look at this. So remember, don't worry about that r for a minute. That r is not as scary as you think it is. But you're going to have to solve for this. Okay? Remember that m equals y2 minus y1 over x2 minus x1. All right? We'll plug in what we know. We are given m. We are given m. That's unusual. So they gave us m. They said m is 2, right? So now, what's y2? Well, let's label. We got r is going to be x1, 5 is going to be x2, 3 is going to be y1, and 9 will be y2. So let's plug in what we know. We know that y2 is 9 and y1 is 3. That's going to be divided by x2 minus x1, which is 5 minus r. Okay, so what I'm looking for is I want to solve for r. This is what I want. I want him all by himself. Okay? So let me show you a couple ways of doing this. We'll see if the second way works. But I'm going to show you algebraically how to solve this problem. My first task is to simplify the numerator, 9 minus 3. That's going to be 6. So let me just rewrite. 2 equals 6 over 5 minus r. Okay? It would be helpful at this point to put 5 minus r in parentheses, because as a denominator, these two things have to stay together for now. All right, now, how do I want to get r by itself, but first I have to get it out of the denominator. How do I get it out of the denominator? Well, remember, if you want to get a denominator out, you have to multiply by the reciprocal. So look, if I multiply by 5 minus r over 1, I can cancel out 5 minus r on top and 5 minus r on the bottom. Just remember, if you do that, you have to multiply 5 minus r on the left side of the equation as well. Okay? And the reason we do that is because you saw it was 6 over 5 minus r. That really is exactly the same thing as 6 over 1 times 1 over 5 minus r. Just think about that. If I multiply 6 by 1, I get 6. And if I multiply 1 by 5 minus r, I just get 5 minus r. So now I'm back to 6 over 5 minus r. Okay? That's why when I do the reciprocal multiplication, I'm putting the denominator and the numerator over 1, because it's really 1 over 5 minus r. So I'm going to flip that. I'm going to flip it and multiply by the reciprocal. Okay, fair enough. Now, usually we put the number in front of the parentheses. So let's just move that around a little bit. Instead of parentheses 5 minus r parentheses 2, we'll do 2 parentheses 5 minus r equals, and the only thing left over here is 6 over 1, which is just 6. So we're getting pretty close. Now when you see a problem like this, you should automatically think distribute multiply. So I'm going to distribute multiply this 2 through the parentheses. So 2 times 5 is 10, and I have a minus, and then 2 times r is just 2r. So I have 10 minus 2r equals 6. Now I want to get r by itself. I want to find the value of r. Okay, so I'm going to subtract 10 from both sides, and I get a negative 2r equals 6 minus 10. Okay, well, what's 6 minus 10? That's negative 4. So now I have negative 2r equals negative 4. Okay, to get r by itself, since negative 2 is multiplied by it, I'm going to divide both sides by negative 2. That cancels on the left, leaving me r by itself, which is what I wanted. So I have r equals negative 4 divided by negative 2. Okay, so just to finish this off, negative by negative is a positive, and 4 divided by 2 is 2, so r equals 2. Just before we stop, let's remember what r is. Let's go back up here. We found r. r equals 2. So that is x1 equals 2. And just to make sure we're correct, let's plug our new value into our formula and solve. So y2 is 9, minus y1 is 3, over x2 is 5, minus x1 is 2. Let's see what we get. 9 minus 3 is 6, 5 minus 2 is 3, we get 6 over 3, equals 6 divided by 3 is 2. So that's a way of checking to make sure that we did our algebra correct. Okay? Now I know this is right. Now this is really what I don't know if it's going to work or not, is to punch this into the calculator. See if we can do this. I'm going to try to punch this into the calculator. I have no idea if it's going to work or not. So the way I'm going to punch in the calculator is I'll go to y equals, okay, and I'll put 2 on one of the y's, and then for another y, I'll put this entire fraction. So I do alpha y equals, get my fraction, I put 9 minus 3 over 5 minus, and then I don't have r on my calculator, so I'll just put an x. Okay, and then second graph. I'm going to look at my table. What I'm looking for is now see, it's giving me an error there. I'm not sure. Maybe I'm looking for the error. I don't know. It's interesting. 2 equals error. Where x equals 5, y equals error. No, here's what I'm looking for. Okay, so just to be clear, that makes sense, because if x was 5, you'd have 5 minus 5, and that would be 0. Okay, so let's look here. You have 2, 2, 2. So what you're looking for in the calculator, if you want to use the calculator, and I actually find this very confusing, but if you find this to be easy, good for you. I'm looking where x, y1, and y2 are all equal. X, y1, and y2 are all equal. And that was at 2. Okay, r equals 2. Okay, so I am the least comfortable with this method. I would really prefer that you solve it algebraically. That way you know you're right, and you can check it that way. Okay, that is the tutorial. Somebody check that calculator method and make sure that I'm doing that right. I know that the algebra is correct when it comes to calculator skills. You know, in many cases, you guys know more than I do, because I'm an old timer. But I'm learning, and I hope you're learning, so we can share our skills and grow together. Sounds like a paradise. Okay, so we'll second quit on that and close down the calculator and close down the video. Thank you for watching.